Hello guys, welcome back to my channel, and today we will discuss about graph colorings. Okay, so where is graph coloring used in which type of problems? Wherever you want to separate. Okay, there are some constraints. We will see one example situation scenario. So you have some constraints like there are two incompatible or two people who hate each other, and we need to put those people into separate groups. So it is for separating groups. So whenever the situation is of separating groups, and how many minimum groups required based on the constraints, that in those type of problems we can use graph coloring or chromatic number. Graph coloring, where the restriction is whatever nodes are adjacent to each other, if they have an edge and have adjacent to each other, we have to color or assign them different colors or different groups. For example, I can color this first vertex green, and whatever nodes are adjacent or having an edge directly with this green node cannot have the same green color. They need to have some other color. For example, the second vertex adjacent to it, I can color it red. Okay, these are mostly used in decision making for resource allocation problems or grouping problems, where you have to separate out groups based on constraints. Okay, so first we will see an example which is called minimum number of prison cells required, so that some of the prisoners, they hate each other, and if we put them in the same cell, then what will happen? They will kill each other. So we don't want that. So this edge is representing enmity between two prisoners. Okay, so how many minimum cells required so that the nodes or the prisoners who are having an edge or they don't like each other, they are put in separate prison cells. Okay, so this minimum colors required so that adjacent nodes are colored differently is called chromatic number. Okay, this is the chromatic number, and it is represented using chi of g. Okay, so let us see what is the chromatic number of this graph. Okay, so I will change the color. Okay, so suppose we will start with this n node. Okay, I assign it group number 1 or color 1. Okay, this green color I have assigned it to n. Now whatever prisoners are adjacent to it cannot be placed in this green colored prison. They have to be placed in a differently colored prison, and I have to use minimum colors. So what we can do is whatever adjacent to it, I will use another color, blue. A is adjacent to n, L is adjacent to n, and this this n is also adjacent to n, and this y is adjacent to n. There are four adjacent vertices, so they cannot be colored green. So we are assigning blue prison cells to these four, and we have to use the minimum colors. Now next we will see, but be sure that we can reuse the colors. Okay, possible colors. For example, see, now this A vertex we will check. Okay, it is adjacent to N, which is colored differently green, but see this L is colored same as A, but they don't like each other, so I have to change the color. Can I reuse the green color over L? No, because L and N will be having the same, they will be put in the same prison cell. That is not allowed. So I have to use a third color over here. I have no choice but to introduce the third prison cell, that is red. Okay. Now we will check this neighbors of L. Okay. L does not like N. They are put in different prison cells. A and L are in different prison cells. L and I. Now, can I reuse the previously used colors? Can I reuse green color? Yes. I and N are not adjacent, so I can reuse the green color. So I will put it in green prison cell. Okay, now let us see the neighbors of I. L different color, N different color. It's okay. Now we will check N. N and I are differently colored. N and N are differently colored cells. N and E. Okay, can I reuse one of the previously used color? Yes, I can reuse the green color. Okay, so let us see. N and E are not adjacent, so I will reuse the green color. And the neighbors of Y we will check. Yes, N different, E different. So this is a valid possible assignment of prison cells. So how many minimum prison cells we require? So all same colored prisoners will be put in the same cell. So A, N and Y, they will be put in prison cell blue. A, N and Y. Okay, and then this green prison will be having N, I and E prisoners, and they there is no hatred between these three prisoners. That is okay, and only L will be put in this red prison. So we have the chromatic number psi of G is 3. We need minimum of 3 prison cells so that satisfying this constraint. Okay, so hope you like my video. So I will summarize chromatic number. In which type of applications can you think of chromatic number, where you have to based on some constraint that adjacent nodes cannot be placed in same group. Okay, you have to assign the colors represent groups or resources. You are assigning resources or assigning or separating the people, and the adjacent people, they cannot be put in the same group or same resource. So you need to have separate resources for the adjacent nodes, and chromatic number represent minimum how to solve the problem using the constraints, minimum how many resources or how many groups you need. Okay, so hope you like this video. Please like, share it with your friends and subscribe to my channel, and stay tuned for more discrete maths video. Bye bye, take care.